All right, so here we go with Chapter 4, Section 1, Simulations of Basic Probability Rules for AP Statistics. So let's get it started. We're going to be going over probability in this section. All right, so first let's talk about randomness. So randomness is basically all around our world. Stuff from tossing a coin, rock, paper, scissors, lotteries, your genes. It was all randomness. It's not really planned out. These are represented what's known as chance behavior, okay, which is we can't figure it out because if you look at small samples, it cannot be determined what's going to happen next. If I flip a coin, you don't know if it's going to be heads or tails. There's no way for us to know for sure. But with these chance behaviors, if you look at them in a long term, so if you look at them in a large sample size, patterns start to emerge. And that pattern that we want to look at is known as the probability of it. And that's what we're going to be looking at with this. Okay, so probability basically is the chance behavior of the unpredicted results over a larger period of time. Yes, if you flip a coin, it's going to be 50-50. If you flip the coin an infinite number of times, you should get 50% heads and 50% tails. But you could flip a coin 3 times in a row and only get heads, or get only tails. It's not that. So with probability, we have 2 different types here. We have empirical and we have theoretical. Okay, so empirical probability is you probably have heard it more as experimental probability, and it is a probability that is found based on observations that were collected. So, example down here, if you roll a dice 10 times and 3 of those came up as odd, the probability was 3 out of 10 because that was what was experimented on. It's the empirical probability of it. So the empirical probability is based on experiments and observations that were done. Theoretical probability is what it would be if you had that infinite number of trials. So if you roll a die, a 6-sided die, an infinite number of times, how many times would it come up as odd? Okay, so how many times would a die come up odd if you rolled it an infinite number of times? And since there are 3 odds and 6 total, it'd be 3 out of 6 or 0.5. So the probability of rolling a die is 0.5. For it to come up odd. Right? So theoretical is what it would be if you did not have an experiment to base it off. If you're just looking at this is what it would be, that's theoretical. Okay, so a few things that you're going to need to know. Number 1 is the what a random event is, and it's whatever the activity that we're doing. So rolling of the die, etc. The outcome is the result of it. So if we have it comes up as a head, or it comes up as a tail, or it comes up as a 7, that's the outcome. The event is a set of similar outcomes. So if I said, my event was rolling an odd number on a die, that's the event, was the odd numbers. And sample space are all possible outcomes, and it's usually denoted as a capital S. And that notation is used as its sample space. Okay, so if you roll or if you flip a coin, heads, tails, that's the sample space. So the sample space is either heads or tails with one flip of a coin. Okay. All right, simple probability. Simple probability is, like in its name, it's simple. It's the easiest way of doing probability, and basically it's the number of positive outcomes or the outcomes that you are looking for divided by the grand total in the sample space. So again, let's do a simple example with heads, tails. If I want to find the probability of flipping a heads, okay, on a coin, how many positive outcomes is that? 1, because you can only, when you flip a coin, there's only 1 event that's heads. And how many total events are there? There's 2 possible outcomes. It can either be heads or it could be tails. Okay. Now, this is used for simple probability. Again, simple, very basic, nothing changes. If the outcomes of each event are the same. So flipping a coin, heads, tails. Okay, they're both 50%. Rolling a dice, each number is 1/6. Okay, that's what it's going to be. So by having all of them have the same outcome, you're able to use a simple probability. Now, if you're doing something like pulling objects out of a hat, but there's more likely chance that this one's going to be like this object's going to be taken over another one, then you can't use simple probability as much. Okay, so let's say we flip a coin 3 times. Okay. So if you flip a coin 3 times and you want exactly only one of them to come up as heads out of the 3, so you want 1 head and 2 tails, what's the probability of that? So what you have to do is you have to find the sample space of it. And so we'd have to find how many possible outcomes are there of us flipping a coin 3 times. And so we would have heads, we'd have 3 heads, we'd have 3 tails, we could have heads, heads, tails, heads, tails, heads, tails, heads, heads, tails, tails, heads, tails, heads, tail, heads, tail, tail. Okay, so those are the possible outcomes, and there's 8 total. So the bottom of our fraction is going to be 8. And then we want to count how many of those only have 1 heads. Now, if you wrote out all those, you'll be able to see that only 3 of them have 1 heads. So the probability, theoretical probability, would be 3 out of 8. Okay? And then the second question is asking what is the probability of at least 1 heads. So the at least 1 means that you can have 1, 2, or 3. So you'd have to count all of them, which means the only one that doesn't exist or wouldn't count for it is the one with 3 tails in it. So that second probability would be 7 out of 8, or 0.875. Okay. All right, here's some probability facts for you that we're going to have. First, probability, whenever you're mentioning probability, you want to mention it either as a fraction or as a decimal. And the decimal should always be between the numbers 0 and 1, with 0 being something impossible to occur, or it will never occur, and 1 meaning that it will always occur. So if you came up with a probability of 7.4, that's obviously incorrect because you can't have a probability larger than 1. That's why we can also have, we could also put it as fractions. So 3 out of 8 would also work. So probability basically answers the question of what would happen if I did this many, many times. Okay, so this is not for it's not going to tell us exactly what's going to happen on the next one. It's going to tell us what's going to happen if we do this many times. So yes, flipping a coin and getting the heads, there's a 50% chance, or 0.5, that you are going to have a heads on this flip. But you could flip it 3 times in a row and you might not get any heads. Okay, this is telling you in the long run. Okay, so this randomness is predictable, again, over a larger period of time. Okay, again, like I've said with warnings, this is not for short predictions. This is for longer predictions. It tells us over a long period of time. And don't get lost into the gambler's fallacy, which is, well, I've rolled 3 heads in a row. That means it's more likely I'm going to have a tail on the next one. That doesn't work because every event is its own event. Okay, so yes, you might flip heads, 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 and the next one still is a 50-50 chance of being heads. Okay, it's not that, oh, it's more likely to be tails, the probability has changed. They have not, because all these events are separate of each other. They're known as independent events. So just because previous events have worked doesn't mean the next events will change because of it. Okay, performing a simulation. All right, so if we're performing a simulation, there are, for the AP exam, you want to follow kind of a 4-step process, and that 4 steps is state, plan, do, and conclude. Okay, so let's go through each one of these one by one. So the first thing is state. So when you are stating something, what you want to do is you want to identify what the variables are. So what's being flipped, what's being used, anything like that. And you want to state the probability in symbols or words, okay, depending on how you want to write it. So just identifying the probability that's being used. Next one after that is plan. And when you're doing planning, you are describing what's happening, the process you're going to go through. So you're going to mention what tools you're using, the values that are being assigned, how you're picking them, the time, how many times you're going to do to conclude it, what's happening with repeated digit or are you ignoring digits, and what are you recording. Okay, so it's just kind of, this is how I'm going to do my probability test. Next one is do. So you're actually going to do the simulation. Okay, if it's under 20 trials, you usually want to include those. So if you do 20 trials or less, you want to include the data itself. If you are doing a larger set, then you just have to summarize, okay, for the most part. And for the most part, you're going to be summarizing. You're not going to have to go like, oh, here's what my actual digits are. It's going to be more, this is what it's going to be. Okay, so you just have to summarize kind of, this is what I got, this many correct, this many incorrect. Last thing is conclude. So you're going to answer the question that was being proposed. So you're going to state your probability. You're going to answer whatever question, and then you want to give your conclusion on it. Basically, the original question, do you agree with it? Is it possible? Is it not possible? Based on the plan that you have done. Okay, so let's do an example so you can have this. So what's the probability of a student earning an 80% on a true-false exam written in Chinese, assuming that the student does not know Chinese? Okay, so in this example, they are just going to be guessing because they have no idea what the questions are or anything. Okay, if a student gets 80% on an exam, should the instructor be concerned that there was cheating? Okay, perform using 20 trials, use the 4-step process. Okay, so this would be a type of question that you could see. And what you'd want to do is you'd want to go through the 4 steps. So step 1 is to state basically what you're doing. Okay, so you want to find the empirical probability, because we're going to do an experiment with this, a trial, and of guessing 80% on questions in a true-false exam. Because it's a true-false exam or true-false quiz, that means each question has about a 50% correct, incorrect probability. Okay, so they are either right or wrong. And so the question is, if they earn 80%, will it be likely that they cheated? So there's your statement. Next is your plan. So what are you going to do to test this? So many different things you could do, rolling a dice, flipping a coin, anything like that you can mention. Since there is true or false, you could say flipping a coin, heads is this way, tails is that way, rolling a dice, even, odd, 1, 2, 3, 4, 5, 6, however you want to do it. This example, I'm using a random digits on a table. And so I'm labeling the numbers 1 through 4 are going to be correct, while 5 through 9 are incorrect. Okay, because that would be 50-50. 5 numbers yes, 5 numbers no. I'm choosing one number at a time from this random table. If they repeat, they are fine. Okay, that's what repeats are okay. And then I'm going to record my digits incorrect and correct. I'm going to do this 20 times. So right there, I'm stating everything, how I'm doing it, what each one represents, and repeats, are they okay, how many times I'm doing it. Okay, next we're going to actually do the experiment. So in this case, I have 9 correct while 11 were incorrect. Okay, just picking them randomly. So out of 20 trials, I had 9 correct, which is about 45%. And that's all you have to do for do, is basically what is the data that was collected based on the experiment. Last, you're going to conclude. So when you're concluding, you go, oh, our simulation was about 45% is what he should have gotten. So since that's so much lower than 80%, we would say that there's probably some cheating going on because it's such a large difference in percentages. Okay. And this would make sense because if you do it in a larger scale, what's going to end up happening is that you're going to end up having closer and closer to 50%. So if I did 100 trials, I'd probably get closer to 50% in the long run, okay? Which is, again, much lower than 80. So yes, the teacher probably should be concerned that there was some cheating on that exam.